All right, everybody, welcome to video here for lesson number 4. So in your packets for lesson 4, there's an opening exercise that is a practice of copying an angle. I know in lesson 3, we hopefully did it in person. Copying of an angle is one of those things that has a ton of steps, but it's not that hard of a concept. You just have to follow the steps as best you can. So first thing we want to do whenever copying an angle is we want to draw a straight line, which I've already provided for you. And we want to label it with whatever letter we want to name this angle as. So let's name this angle as point P, like they want us to. So we're going to call this point P. Now to perform this construction, the first thing we want to do is we want to open up our compass so that it is a random size. It does not matter how big we make this, so we're going to make this a random size from W. Try and get it right on W. Again, on your safety compasses, you're just opening up that little piece in the middle there, however big you want. And we're going to make an arc. Make sure that arc intersects both rays of this angle, and then make the same exact size arc from point P. It's important that it's the same exact size, so we want to do this right away so that the compass doesn't change in size. Now this new point that we've created here, right? So this new point that we've created here that I'm making in purple is the distance that's the same here. Now we want to measure how big this opening is so that we can recreate this point someplace on this blue arc. So to do that, I want to use my compass like a measurement tool. So I'm going to use it like I'm measuring something. Actually, let's do this in green. This part is a little bit different. So we're going to measure between these two pointed locations. Whoops. So let's see here. We want to expand this a little bit. I want to turn this a little bit. And we want to get it so that this is the right size, this right distance. Oh, looks good. I want to just make a little mark here. I want to recreate the same thing from this purple point. Because if I recreate the same thing, wherever that blue line and green line intersect is going to be the point where, well, that second ray is. So now all I have to do is recreate this point. Here's my point. And I want to draw a line from that original point, point P, and have it go through this new point that we've created. I've just copied my angle. Again, not the hardest construction in the world, but a lot of steps, a lot of thinking involved here in that construction. Okay, so now that we've reviewed what we needed to know from lesson 3, let's look at a couple pieces of vocabulary here. So what is a right angle? So to have an angle that's considered a right angle, I'll write in blue today, let's see. A right angle is an angle that measures 90 degrees. So if I was to draw a right angle, it's going to be two rays that intersect at a point. We'll call this point B. The ray has to pass through other points, so we have A and C. To name an angle, we would call this angle ABC. The middle letter is always where the angle is created, so that's where the 90-degree angle would be. Perpendicular is when two lines or segments or rays intersect, forming a 90-degree angle. So we can have two segments that intersect at 90 degrees. So here's two segments. We could have two lines that intersect at 90 degrees. Or we could have two rays that intersect at 90 degrees, like I drew above. Now, one of the things that we have to remember is just because something's perpendicular doesn't mean it's getting cut in half, right? If I look at this example, this first example I drew, right, those two line segments were not cutting each other in half. Equidistant is something that we defined already. It's said to be a set of points that are equal distance when they're in equal distance from two or more things. So if I have 2 points like point A and point B, there's a sequence of points that are all equal distance from point A and B, this line coming through the middle, right? Every distance is going to be the same from A to B to that dotted line that I drew. That dotted line just so happens to also be perpendicular to the segment that connects points A and B. And that we're going to use today in our construction and within our lesson. This is a big concept. We're going to be talking about this a lot. So what we're constructing today is something called a perpendicular bisector. This is probably the most important construction because we're going to use it throughout the rest of this chapter. You're going to be perpendicularly bisecting pretty much all the time whenever we're looking at different types of constructions because it cuts things in half and it makes 90-degree angles. So what does the perpendicular bisector of a segment AB is a line that is going to be perpendicular to AB and passes through the midpoint of AB. So not only are we creating something that's a right angle, we're also cutting a segment in half. Now I know you don't have a ton of room on your page here, but I do want to just give a example of what a picture is going to look like here. So in this diagram, I have a line CD and a line segment AB. If CD is the perpendicular bisector of segment AB, I know the following things would be true. I know that AM is congruent to or equal in length of BM. I also know that CD, the line, is perpendicular to AB, the segment. Symbols are, we're going to use a lot of symbols here, right? Remember, congruent means that they're the same size, right? So these little segments are the same exact size. All right, so moving right along, let's construct a perpendicular bisector, right? Because we want to be able to construct a perpendicular bisector here, so we want to be able to create this. So let's experiment here for a second. If I want to create a perpendicular bisector, that means I want to create something, right, that is going to have the midpoint of this segment on it and make it a right angle. So let's start with just the midpoint piece, right? Let's just start with the midpoint piece. To cut something in half, I want to make it so that I'm an equal distance away from point A and point B. I want to get to the middle. So equal distance, we know how to find equal distances. It's like the equilateral triangle construction we did in lesson 1. So I'm going to open up to the length of AB and make a mark. If I make the same mark from point B, I've just created two locations that are an equal distance away from both points A and B. So let's mark those locations. So here's a location up here, and here's a location down here. Both of those red dots are the same distance from A that they are from B. They're equidistant. Meaning, if I was to draw a line that connected those red lines, right, let's get a line here. So let's get a line. So we have, we'll use a dotted line. That'll even be better, right? So if we draw a line that passes through both red dots, okay, that line, that line is going to be perpendicular to AB. It's also going to pass through the midpoint of AB. So this line becomes the perpendicular bisector. So let's name it. Let's call this, we'll pick a point randomly on here, call it C. We'll put a point randomly on here, call it D. So we can say is line CD is perpendicular to line segment AB. Line segment AB gets cut into two equal pieces. So let's call this point M for midpoint. So what else do we know about this picture? I know that AM is congruent in size to BM. I know that angle AMC is right. Right, that would be this angle here. Actually, all four of these angles are right in the middle, but we'll just choose one of them. There's a lot we know about this. And all we did was we did the equilateral triangle construction on both the top and bottom of the line segment. All right, Same thing's happening in this next problem. So in this next problem, I've now reconstructed what we just did on the previous page. I didn't make all the arcs and all of that stuff, but I basically have the same scenario. I have a segment that's being cut by this vertical line CDE, and it's being cut in half, and it's at a 90 degree. It's a perpendicular bisector. So what I want you to do is use your straight edge on your compass, and I want you to draw some lines. If you have different colors at home, try and use different colors. It'll help. This distance from C to A and this distance from C to B, I want you to take a look at. What do you think those distances are to each other? Then I want you to take your compass and again make a straight line here from D to A and from D to B. And do it one more time. Again, if you have colors, great. If you don't, no big deal. And make it from A to E and B to E. All right, so after you've done that, and you have all your lines drawn in here, let's talk then about, well, what do we know, right? What do we know? What do we know about all of these segments, right? So what we can say is the segments that are the same color are the same length, right? So we can say AC is congruent to BC. We can say AD is congruent to BD. And we can say AE is congruent to BE. I know that because the perpendicular bisector creates a set of equidistant points from point A and from point B. Anywhere on this line is going to be the same distance from A and B. And the word that we used there was equidistant. So any point on that perpendicular bisector is going to be equidistant from the endpoints of that segment, any one. That's one of the nice things that a perpendicular bisector does for us. Example 3 we're going to skip. It's something that we don't need to do. It's kind of fun and exciting. If you want to try, you can even go on YouTube and just YouTube this. If you want to, I promise you can find that construction on YouTube if you really are interested. If not, no big deal. You could just move on and do whatever I'm giving you for homework for tonight. Okay? Hopefully this video helped, and I'll see you all soon.